All right, so we're looking at section 5.3 today, similar triangles. So we looked at similar polygons yesterday, or in the last lesson, so similar triangles is today, and it is similar to yesterday's lesson. All right, so there's 3 different ways that we can determine if triangles are similar to one another. The first way we can tell is by angle-angle similarity. So it says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So all we need to prove is that 2 angles of one triangle are congruent to 2 angles of another triangle. The second theorem is side-side-side similarity. And what this says is if we have 2 triangles and all of their sides are proportional, then we know the 2 triangles are similar. And last but not least, we have side angle side. And so this one says if the measures of 2 sides of a triangle are proportional to 2 measures of another triangle and the included angle is congruent, then we know that the triangles are similar. So what they mean by included angle, so if I look at side PQ and we say that is corresponding to side TS and they are proportional to one another, and then we say QR and then side SU, if we know those 2 are proportional, the included angle is the one that is created by those 2 sides, because remember we need 2 sides to create an angle. So therefore we have side, angle, side, side, angle, side. So the angle just has to be between the 2 sides. So if we know that, then we know that the 2 triangles are similar. So our first example, it says, in this figure, we know that AB and DC are parallel. They told us that, and they are showing it in the figure by the triangles. And angle ABC and DCB are right angles. So ABC, so this is a right angle, and DCB, that one is a right angle. It says determine which triangles in the figure are similar. So the first thing we have is that we have 2 isosceles triangles here. So the 2 isosceles triangles are CED and EAB. So looking at those 2, that sort of makes me think that we could do something with that, but we do also have those 2 right triangles. But we're going to look at the isosceles triangles first. So for these isosceles triangles, their sides could be proportional, but we're not really sure. All we know is that it's isosceles, so 2 of the sides of the larger triangle are equal to each other, and 2 of the sides of the smaller triangle are equal to each other. So let's take a look at their angles now. Erase this so we don't have quite as much going on. So if we take a look at their angles, since CD and BA are parallel, C to A would be our transversal. So we know that these 2 angles are congruent because they're alternate interior. Following the same reasoning, CD and BA are congruent. B to D is our transversal. So therefore, angle D and angle, this part of angle B, those 2 are also congruent. So we could technically stop there and say, hey, look, angle-angle similarity, so we are good to go. So I'm going to go ahead and write that angle-angle similarity, and then we can say that triangle ABE, so I did ABE, so I did the base, the vertex, the base is similar to, so I need to do a base, a vertex, and a base, so I'm going to do CDE. We also could have shown that this angle E and that angle E, that those 2 are also congruent because they're vertical angles. So we did determine that those 2 triangles are congruent. Now take a moment, stop, double check, do the your turn, and then come back to the video. All right, so for the your turn, it gave us some side lengths, so we're probably going to have to set up proportions. It says O to W is 7, B to W is 9, W to T is 17.5, and W to I is 22.5. So we have to say which of the triangles are similar. So in order to do this, we know that, let me see, this side is going to be congruent to that side. So in this case, I'm just using these tick marks to show, I'm sorry, not that they're congruent, but those two are the ones that are corresponding. So now let me say, oh, I already used green. Let's look, TW is corresponding to this one. And if you're wondering how I'm figuring this out, O to W looks shorter than B to W. Well, not only does it look that way, we know it's shorter because that one's 7 and B to W is 9. So that must mean this shorter side, 17.5, must go with 7. And then we know our last side, those two are corresponding to each other. So again, I'm not using these tick marks to show congruency. I'm just using them so that we have a frame of reference as to which sides go together because the figures are not oriented the same way. So now let's set up our proportions. We are going to do 7 over 17.5 is equal to 9 over 22.5. So if these are proportional, they should come out to be the exact same. So if we take 7 divided by 17.5, we get 0.4. And if I take 9 divided by 22.5, look, we get 0.4. So therefore that checks out. The sides are proportional. So now we just need to say, okay, we need to look at all of our similarity statements and figure out which one's in the right order. So this one does, the first one, A, does O, B, W. So it did the one side, the black side, the red side, then the orange side. So it did black, red, orange. So this next one, I to T to W, it did the black side, but then it did the orange side and then the red side last. So that one doesn't work. And now if they did O, B, W, O to B to W, so they did the black, the red, the orange, black, red, orange, W-I-T, so W to I, well, that already starts off with the red side, so I don't even need to figure out the other one. So that one's not right. We have it narrowed down. So B-O-W, B to O to W, so black, orange, red, black, orange, red, T-I-W, well, that did black, red, orange. Oh, no, so it looks like that one doesn't work. I'm hoping this last one works, or else we need to go back and double check. So B-O-W, black, orange, red. Black, orange, red. And then I to T to W. Oh, lo and behold, that one went black, orange, red. So that makes D our answer for the similarity statement. So hopefully you were able to get that one right. All right, moving right along to try to make my videos slightly shorter. It says, we know all of these properties are true. We've done them way back towards the beginning of the year. Remember, reflexive property just says something is congruent to itself, but these are similarity statements, so something is similar to itself. Symmetric, if I have triangle ABC is similar to DEF, then I can switch the order. I could do DEF is similar to ABC. And finally, transitive, it says if ABC is congruent to DEF, and DEF is congruent to GHI, then we know that ABC is congruent to GHI. So if you remember back in class, I simplified this a little bit. I said, okay, if A is similar to B, and B is similar to C, then we know that A is similar to C, because sometimes that's a little bit easier to look at than 3 letters naming everything. All right, so let's keep going with example 2. Example 2, we get to do a little bit of algebra, and I know you're all super excited for that. So it says, given that RS and UT are parallel, we know that RS is 4, R to Q is x plus 3, Q to T is 2x plus 10, and U to T is 10. We have to find, and let me highlight these, we have to find RQ, and we have to find Q to T. So pretty much in order for us to find those two, we have to find x first. And then once we know x, substitute it back in, and we are good to go. All right, so set up proportions, because since this deals with sides, that's what we have to do. So I'm going to do 4 over 10 is equal to, now I only know those two other sides, so we're going to have x's in both the numerator and denominator. So x plus 3 is over 2x plus 10. So we are going to cross multiply to solve this, remember from the first day. So 10 times the quantity x plus 3 equals 4 times the quantity 2x plus 10. Distribute everything, so 10x plus 30 is equal to 8x plus 40. Subtract 8 from both sides, we get 2x. Subtract 30 from both sides, we get 10. So therefore, x is equal to 5. So that looks good so far. But don't forget, we're not done. It asked us for RQ and QT. So to find RQ, we have to do x plus 3, but we just found that x is 5, so 5 plus 3. So RQ is equal to 8 units. And to get QT, that is equal to 2x plus 10. So 2 times 5 plus 10. And 10 plus 10 is, oh, there's nobody here to answer me. It's 20. Oh, my daughter answered me. Good. So QT is 20. Perfect. All right, you guys go ahead and do the your turn. I'm going to go through the your turn. I may not explain it in detail because we were told to make our notes shorter, so our video shorter, so I'm going to just go through it so you guys can check it on your own. All right, so last example. It says, Josh wanted to measure the height of the Sears Tower in Chicago. He used a 12-foot light pole and measured its shadow at 1 p.m. The length of the shadow was 2 feet. Then he measured the length of the Sears Tower shadow, and it was 242 feet at the same time. What is the height of the Sears Tower? So look, this is our first one that says drawing not to scale. So you don't just get to hear it from me, we get to actually see the words. So we actually have two triangles here. There's just one inside the other one. So we have this really big triangle. I probably should have used the highlighter. That's the triangle of the Sears Tower and its shadow, because remember, you see the shadows on the ground. And then we have this smaller triangle. That's Josh. He's standing there. And there's his shadow on the ground of 2 feet. So if it helps, you might want to draw them separately. I don't have a lot of room on here, so I'm going to keep them together. But pretty much we have the right leg of our triangle that's going vertically for both, and we have the other leg of our triangle, which is our base that it's sitting on. So that's how we're going to go ahead and set up our proportion. So I'm going to do the height. Maybe I should write them out in words. Height over shadow. All right, so the height of the Sears Tower is X. What is the shadow of the Sears Tower? And that's 242. We know the height of Josh is 12 feet. I'm sorry, that's not Josh's height. What is that the height of? Oh, the light pole. I was going to say a 12-foot person. So the light pole, I'm sorry, is 12 feet and its shadow is 2 feet. So then to solve this, so that we can find the height of the Sears Tower, we need to cross multiply. So 12 times 242 equals 2x. And we get 2x is equal to 2,904, and that leaves us with a value of 1,452. So that means the Sears Tower is 1,452 feet. And I remember one of the classes looked this up, and that was actually pretty accurate, so that's good. All right, last your turn for this section. So you guys go ahead, read through the problem, try it out on your own. I'm not going to talk. I'm just going to show you the work, and then I'll say something towards the end. Oh, I guess I have to talk on this one. All right, so 5 feet 6 inches. Remember, that's 6 inches. It's 6 inches out of 12 inches. So we can't just say 5.6. 6 out of 12 is 1/2, and 1/2 is a decimal is 0.5. So if you convert everything, that means this height is going to be 5.5. Oh, everything's 6 inches. So 53 feet 6 inches is 53.5, and 1 foot 6 inches is 1.5. All right, so then go ahead and set up your proportions. Remember, there's 4 different ways to set it up. So I'm going to do x over 53.5 equals 5.5 over 1.5. Right? If we go and cross multiply, I get 1.5x is equal to 53.5 times 5.5. That's 294.25. Divide both sides by 1.5. We get the height of this lighthouse is 196.117 feet. But they said, what is the height of Cape Hatteras Lighthouse to the nearest foot? So what do you think we should put? 196. All right, so hopefully that made a little bit of sense to you. I look forward to you for section